Okay, so we've got volume of prisms and cylinders. Again, we're grouping these two together because they've got those two congruent and parallel bases. Their volume formulas are going to be very similar as well. We define volume as the number of non-overlapping unit cubes that fit inside a solid figure. Okay, and we use unit cubes. This could be inches, centimeters, miles, kilometers. It could be anything. Okay, so that's why we say unit cubes. Okay, and this guy, Cavalieri, he had kind of this idea or thought and put it to a test, and he ended up getting this Cavalieri's principle out of it. And it says if two 3D figures have the same height and same cross-section area, then they have the same volume. Okay, and that cross-section, remember, that's when we're cutting it horizontally, vertically, and creating a figure, a triangle, a circle, a rectangle, depending on what kind of shape that we're talking about, that cross-section. Okay, so for prisms, for our volume, just two different looks at them here, your triangular prism and your rectangular prism. Both are going to have the same volume formula, okay, which is on your sheet, the big base, so B times the height, which is just the area of the base. Okay, this is on your sheet, on your formula sheet, the area of that big base. Now, for a rectangular prism, a lot of times you've already seen it, it's still volume equals big base times height, but that big B volume is just your length times your width. Okay, so these two are exactly the same. Your big B is that length times width. Rectangular prism's volume, super easy. Length times width times height. Triangular prism, ooh, this one, the big B here, is going to be 1/2 the base times the height, and we're not talking about the height of the prism, we're talking about that height of the triangle. Okay. And then for cylinders, they also have a pretty similar one. We can call it big B times H. Okay, a lot of times we just write this as pi r squared. Okay, big B is the area of the base, which is going to be pi r squared. That's what we have. We have a circle, so we're talking about pi r squared. Okay, so just a couple examples. We have a rectangular prism. The volume for this is that big base times height, or length times width times height. Okay, I see that my base is probably these two squares. These are the two that I have, the two front ones. So my base is actually 16 by 9, and my height is 4, which gives me volume as 16 times 9 times 4. And I can just plug that right into my calculator, and I get 576 centimeters cubed. Okay, we're talking about cubic units. Okay, for volume. So now we're multiplying 3. We multiplied centimeters times centimeters times centimeters, which means we've got 3 here for our cubic units. Okay, last example, a cylinder. Again, we can call this big B times H, or pi r squared times that height for the volume. Okay, So we have pi times our radius 8 squared times our height of 10, okay, which gives us pi times 64 times 10. You can always leave this in with pi, millimeters cubed. Again, we've got 8 millimeters for 2 of them, and then 10 millimeters, so we've got cubic units. Or I can put this into the calculator and get approximately 2010.6 millimeters cubed. Either answer is fine. Either answer correct for this. Okay, short one for this.